Okay, welcome to our next video lesson on the cross product of algebraic vectors. So on Friday we looked at the dot product of algebraic vectors and we saw how simple it was. We just multiplied the x coordinates, the y coordinates, and the z coordinates, add them together, and we end up with the solution for the dot product. One thing that we have to recognize that is different is that when we do the cross product, remember the cross product gets us a vector, a new vector. So when we did the dot product on Friday, it was the answer was a scalar, but here it's going to be a vector. But it's still rather simple. So here we have the cross product, and we're given two vectors. U equals U1, U2, U3, and V is V1, V2, V3. And there's just a formula to get the cross product, and it's very simple to remember. So I'll quickly show it to you. Here it is. So quite simply, to take the cross product, all you have to do is do U2V3 minus U3V2 for the first component. For the second, it's U3V1 minus U1V3, and simply for the third one, it's U1V2 minus U2V1. Simple enough, right? So I'll give you a second to write that down. And hopefully you'll also realize that, in fact, it's actually not too difficult to remember. If you want to find the first component, you have to multiply the second and the third. And you first start with the second component of the first vector times the third component of the second vector, and then you subtract the third component of the first vector times the second component of the second vector. All of this is for the first component. And then, of course, you do the same for the second component, where you look at the third from the first and the first from the second, minus the first from the first and the third from the second. And for the third component, you ignore the third component and use the first and second components, using the first from the first, the second from the second, minus the second from the first and the first from the second. So I don't know how I can make this any other easier, but it's obvious to me. So let's actually try and do it. So we're going to use this to try and find the cross product of these two vectors. The first vector is U, 3, 2, and negative 1, and V, 2, 1, and negative 3. And hopefully you've been able to notice the sarcasm in my voice, in that I don't expect us to memorize this formula. It is one that I'm going to show you a little trick to help you remember. So this little trick is similar to the TV tray that you use for factoring or SOHCAHTOA to memorize something. It's a gimmick that you can do off to the side that will produce the cross product. It does do the actual formula there, but it's a nice little way to do it. And the way it's done is, what I call it the down products minus the up products. If you look at the formula, we do have a couple of products and they're being subtracted, so that's where this comes from. Now, I'll show you how this works. So pay close attention. We are going to take the first vector and we're going to write down its components twice. So we're just going to write down the components, 3, 2, negative 5, and then write them again, 3, 2, negative 5. Then we're going to do the same for the v component, or the v vector, and put it underneath. 2, 1, 3, 2, 1, 3. And like I said, this is a little thing you might do off to the side. You'll do it off to the side of the question, but we write this down first. Then we ignore the first pair and the last pair. And we only look at the ones in between. And here's where the first component of our vector answer comes from. We take the down products, so it's 2, times 3, which is 6, minus the up products. So minus the up product is 1 times negative 5, and we write that down. That is going to be our first component to our vector answer. Actually, we'll keep the curly brackets. So this is the first component. So it's 6 minus 5, which is 11. Then we go to the next pairs and do the same thing. The down components, or the down products, negative 5 times 2 is negative 10, minus the up products, which is 3 times 3, so minus 9. And negative 10 minus 9 is negative 19. And then the third one is 3 times 1, which is 3, minus the up product, 2 times 2, so 3 minus 4, and that equals negative 1. And then we have our answer, which is a new vector. And the new vector answer is 11, negative 19, and negative 1. So U cross V is 11, negative 19, and negative 1. Now, I think there's a question in your homework later on that asks you to use this little gimmick, this down products minus the up products, but use the components U1, U2, U3 to prove that this works. But if you think about it for a second, remember this is actually U1, U2, U1, U2, U3, and this is V1, V2, V3. I don't expect you to write this stuff down in blue, but notice that by ignoring the first two, we end up with U2 times V3, which is right there, minus V2 U3, which is right there. And then of course it gets repeated. This pair is looking at the third and first, and then this pair is looking at the first and second. So it's a nice little way, and really I want you to practice this in getting used to the down products minus the up products, because we'll have to do this quite a bit in the next couple of units.